Artificial neural network, inspired by human neurons. The human neural network works by connecting a vast number of neurons. These neurons store information and communicate with each other to transfer and process data effectively. Similarly, artificial neural networks, ANNs, are modeled after human neural systems. They consist of interconnected neurons. Each connection, or edge, between neurons has a value called a weight. These weights play a critical role in determining the behavior of the network. In an artificial neural network, data flows through layers of neurons. Each layer aggregates inputs, processes them, and passes the result to the next layer. The process begins with input neurons, where data enters the network. Depending on the problem, the network processes the data and learns optimal weights. This learning enables the network to make accurate predictions on new, unseen data. Explanation on a sample. For instance, consider a task where we want a neural network to distinguish between images of handwritten digits from 0 to 9. To achieve this, we provide the network with a large set of labeled images, where each image is associated with the correct digit it represents. Over time, the network learns patterns and features from these images. Once trained, it can accurately classify new images, identifying which digit is shown in each case. The structure of this neural network could be designed as follows. All images should be standardized to the same size, example, 28 by 28 pixels. Consequently, the network's input layer would consist of a flattened array with 784 elements. 28 by 28. The number and size of hidden layers can vary depending on the complexity of the problem. The output layer would have 10 neurons, corresponding to the 10 possible classes, digits 0 through 9. Initially, the weights in the network are set randomly. For each input image, handwritten digits from 0 to 9, the network assigns the input to one of the classes. This classification may be correct or incorrect. Based on the result, the network adjusts its weights to improve its accuracy. This process is repeated for all training data. Once training is complete, the model is evaluated on a separate test dataset. If the accuracy meets the desired target, the model is ready for deployment. If not, additional training or tuning may be required. This is the power of neural networks. They enable machines to learn and make predictions based on examples, simulating a simplified version of human learning. What is deep learning? The terms deep learning and neural networks are used interchangeably because all deep learning systems are made of neural networks. However, technical details vary. There are several different types of neural network technology, and all may not be used in deep learning systems. In a simple neural network, every node in one layer is connected to every node in the next layer. There is only a single hidden layer. In contrast, deep learning systems have several hidden layers that make them deep.